Welcome to another lesson. So today we're looking at transformers, right? So a transformer is a device that alters the voltage being supplied to it. So that altering can be either it makes it higher or it makes it low, all right? So with that, to represent our symbol for transformer in our circuit, we normally use two coils, right? So one on the left, one on the right, right, to represent a transformer. Now the type of transformers we have would be to make it higher, which is step up, or to make it lower, which is step down. All right. So we're just going to look now at how can we look at a transformer and know if it's a step up or a step down transformer. So for what? In order for it to step up the voltage, right, then we know that there are two sides of a transformer. So we have the primary side, right, and the secondary side. So the primary side is where the voltage being supplied to, right? So from your AC supply, it gets its primary voltage, right? And then it induces the voltage on the secondary side. So the secondary side, for it to be a step up, it needs to have more turns in your coil. So that's how you know if it's a step up. That means for a step up, your number of turns in your primary would be less than your number of turns in your secondary. All right, so the number of turns determines how much voltage it will have. All right, and then for step down, then NP would be greater than NS. All right, because you're getting a lower voltage on your secondary, so you're reducing the number of turns on that side. All right, so the parts of a transformer shows us here that we have a core, right, that separates our primary coil from our secondary coil. All right, so our primary voltage is the voltage between the two lines, the two extremes of your primary coil, right? And this labels our primary coil being wrapped around the core. All right, and our secondary coil is on the next side with our secondary voltage that's being supplied. So remember, our primary voltage is a voltage that comes from our AC supply, right? So we are only able to use a transformer using AC supply. So DC supply does not work with a transformer because there is no change in direction, right? And you need that change in direction in order to induce the voltage on the opposite side of the secondary coil. All right, so this is basically how the transformer looks, right? So we have a core, a soft iron core, that's on one side we have the primary coil, and on the next side we have the secondary coil. So the primary coil is connected to your AC supply, right? And your secondary coil is connected to the appliance or whatever load that you want the voltage to be applied to. All right, so let's look at now how create these transformers. How do we get the efficient performance from our transformers? So the first is to use a soft iron core. Now the reason for a soft iron core is because the softness actually talks about the magnetism of the iron. So how well is it able to be magnetized? Because when current, remember lesson yesterday, when current passes through a wire, right, it produces a magnetic field, right? So that magnetic field on our primary coil will be induced a magnetic field in our core. So this makes our core becomes magnetized, right? So we need a metal that is easily magnetized, right? So that means we don't need a lot of current here in order to get the metal to be magnetized, right? So that's the purpose of the soft iron core, because it's easily magnetized. Next is to laminate the core, right? So laminating the core means to put an insulating sheet over the core. And the purpose of this is because when we induce the magnetic field in the core, it also induces a resistive current, which is known as your eddy current, right? So laminating it will actually reduce the effect of the eddy current that is being produced. So the eddy current is a resistive current that if the current will be going in this direction, your resistive current is going the opposite direction, trying to slow down the occurring, right? So in that case, we laminate it, put an insulating sheet around it, so it actually reduces the effect of the eddy current, right? And then lastly, we can use low resistive wires, right? So for our coils, we use very low resistance wires because we know that we need a very high current to be passing through our core, right? And remember from Ohm's law, the relationship between voltage and resistance, right? So therefore, I is equal to V over R. So if we have a low R, we're going to get a very high current being induced in our core. All right, so those are the three main factors that affects how efficient the transformer can be made, right? Now, let's look at that equation, right? So the transformer equation actually takes a three-part situation. So three quantities that are there. So we have N representing the number of turns, V represents the voltage, and I represents the current. So NP is the number of turns in your primary coil, NS is the number of turns in your secondary coil, VP is the voltage in your primary, Vs is the voltage in your secondary, Is is the current in the secondary, and Ip is the current in the primary coil, right? So please note that the P's of the V and the N actually goes to the one side, the same side, right, of your division side, right? But the Is changes. Now, in some books, you will see NS, VS at the top, right? So just note that once you have N and V, the same primary or secondary, it's the reverse for the I. So if you have NS, VS, then this would be IP, right? So that is very important when you're looking at the equation, right? Because sometimes it gets confusing which one of these actually does not obey the P over S, and then this one is S over P, all right? So for ideal transformers, there is something that is important. Ideal means that it's 100% efficient. And if it's 100% efficient, then the power that's inputted on the primary side is going to be the power that exits the secondary. So power out is equal to power in, right? And we know that power is equal to I times V, current times voltage. So therefore, the current in your primary times the voltage in your primary is equal to the current in your secondary times the voltage in your secondary. All right, so that's it for transformer, guys. I hope you guys understand something about transformers and can use it to actually work better in the future. All right, so thank you very much for watching, and see you guys next time.